Okay, so before we start, I have a question for you. I have solved this question using the concepts that we learned in equations of motion. Now, my question to you is, can you solve this question using any of the topics that we have learned in laws of motion or in work energy power individually or a combination of these three? Okay, so try thinking on that. In the meanwhile, for a train engine moving with speed 20 meter per second means u is 20 meter per second. The driver must apply brake at a distance of 500 meters. So we have distance of 500 meters before the train for the train to come to rest, which means the velocity becomes zero as it comes to rest before the station, right? Before the station. So this station, this comes before the station. This is the track. So in this situation, if we apply equations of motion, what we get is v square minus u square is 2as. 0 square minus 20 square is 400, is 2 into a, distance is 500 meters, so is a 2a into 500, and therefore what we get is a is equal to minus 4 by 10, and it has to be negative. Why? Because the train is decelerating, right? Now it is also given the question that retardation is produced by the brakes is same. Why is that important? It is important because in the second half of the problem, if the brakes were applied at half of this distance, which means when the first condition it was 500 meters, and if the brakes are applied only at 250 meters, it is given that the train engine would cross the station with a speed of, which means it will cross the station with a speed of. Well, I think it should be coming like this, right? Because it is crossing the station. Yeah. So what will be the velocity when the train crosses this station is the question, right? If the brakes were applied at half the distance. Okay. Now in this case, which means this. Okay, I think it's better to keep this train over here, right? Because it has entered, it has started moving across. Yeah. Okay. Now, in this case, v square minus u square is 2as. V square is not 0 because the train is not coming to rest. It is still in motion because it's crossing the station. U square is 20 square. 2 into a is minus 4 by 10. How is a the same here? Because it is given that the same retardation is produced by the brakes. So a is minus 4 by 10. Into s given to us is 250. So v square would be equal to minus 1825. Why? Because 250 by 10 is 25. 2 into 4 is minus 8. I'll transpose minus 200 minus 20 square, which is minus 400 to the RHS. That becomes plus 400. 25 into 8 is, if it's a 14, 16 plus 4 is 20, minus 200 plus 400. So we have v square is equal to 400 minus 200, which is equal to plus 200, and therefore v is equal to root of 200. It is given to us in the question that the final velocity would be root x meter per second. So if v is equal to root x, then by comparing these two, we have that the final value of x would be equal to 200.